Welcome to your Get That Nugget for GCSE Maths. Today we're going to be concentrating on giving you a framework to answer questions about converting with standard form. This session is to complement your lessons with your teachers and it is not to replace them in any way. Okay, so what we're going to do in this session is we're just going to focus on converting standard form. There'll be another session on doing calculations with standard form, but for this one we're just going to focus on those conversions. Now, with standard form, there is something key that we have to remember. So I'm just going to make a little side note here. And the thing we have to remember with standard form is that we always have a number. Now, I'm going to represent that with A because it can be any number. However, this number has to be between 1 and 10. Now, this number can equal 1, so I'm going to underline my inequality here to represent equal to, but it cannot equal 10. So a number between 1 and 10, inclusive of 1, but not inclusive of 10. So we could have 1, 2.3, 8.9, anything like that, just not including 10. Standard form also has then a multiplication sign, and it's always multiplied by 10 to the power of something. Now I'm going to represent that as an n. Now this n is our power, and this can be a positive and a negative number, and we're going to look at what cases it may be positive and what cases it may be negative in a minute. But this is what we must remember. The first bit has to be between 1 and 10. Can be 1, can't be 10. Always multiplied by 10 to the power of something. So if we have a look at these here, which of the following are in correct standard form? So this 0.6 times 10 to the power of 3, this would not be in correct standard form. And the reason for that is this first bit here. So the first number, 0.6, is less than 1, so it's not in correct standard form. This one here, 12 times 10 to the power of 5, again, not in correct standard form. And our reason this time is because 12 is greater than 10, okay? This one here, 1.753 times 10 to the power of 4, incorrect standard form. 1.753 is between 1 and 10 times by 10 to the power of 4. This is correct standard form. This one here, 2.56 times 100 squared. Well, 2.56 is correct. It's between 1 and 10. However, times by 100 is not correct, which means that is not correct standard form. Remember, our last bit has to be multiplied by 10 to the power of something. So if we have a look at this then, so write 9,000 in standard form. Now, the way we do this is we look at our number and we need to use our digits to essentially find a number that's between 1 and 10. Now, if I look at these digits here, I can see that I've got 9. So what I'm going to do is I'm going to say 9. Now, what some of you might be able to recognise is that all we have to do really when we've got 9,000 is we need to do 9 times by 1,000. I could write 9 times by 1,000. Is that in correct standard form though? No, because we know that it's got to be times by 10 to the power of something. So what I'm then going to do is I'm going to say 9 times by 10. Now, 1,000 is equal to 10 cubed. 10 times 10 is 100. 100 times 10 is 1,000. So 9 times by 10 cubed. Now, a quick way for you to do that is we've realised that 9 has got to be our first number. And what you can do is you can say this is where we've cut our number off and we can count our jumps to the end of the number. 1, 2, 3. That is then our power. Might make it a little bit easier when we have things like decimals here. So here we've got 360,000 in standard form. Now this time we've got 2 digits. We've got a 3 and a 6. Now if I was to isolate this and say 36, that's not going to be in correct standard form because we know it has to be between 1 and 10. So the way I'm going to do it is I'm going to insert a decimal and I'm going to make it 3.6. Now, all we do here is we say, right, this is where we've inserted our decimal between 3 and 6. And so we count our jumps to the end of the number. 1, 2, 3, 4, 5, times by 10 to the power of 5. This explanation here is explaining why we do our jumps. This here, as I said, it's just a nice quick way to be able to do this. Okay. This time we've got 5 times 10 to the power of 7 as an ordinary number. What this means is we just want to write it as a normal number, not in standard form. Now we know we've got 5, so we know our first number is going to start with a 5. Times by 10 to the power of 7. Because we've got no decimals here, all I can do is I can just put 7 zeros on the end. 1, 2, 3, 4, 5, 6, 7. So our number here, 50 million. Okay, let's have another example. So write 7.6752 times 10 to the power of 7 as an ordinary number. Now, this time we can't just put our zeros on the end because we've got a decimal. We haven't just got that one digit number. So the way we're going to do this is we're going to write all of our digits out without the decimal. 7, 6, 7, 5, 2. Now, we know that we've got multiplied by 10 to the power of 7. This time, as I said, because we haven't got just a single number, we can't just add 7 zeros on the end. This time, we're going to count how many jumps to get to the end of this number. So we go 1, 2, 3, 4. Now you'll notice I started my jumps from where our decimal was. So our decimal was here between the 7 and the 6. So our decimal, we've jumped 1, 2, 3, 4. However, because we're times 10 to the power of 7, we still need to do 5, 6, 7 jumps. And then all we're going to do is we're going to replace under here with zeros. So our number $76,752,000. Okay, now this time we've got really small numbers, so write 0.0007 in standard form. Now these are ever so slightly different to the examples we've just done, but we're still going to follow the same method. There's just one slight change, which I'll show you in a second. So again, all I'm going to do is I'm going to pick my digit. Remember that it has to be between 1 and 10, so I can recognise the 7 there is between 1 and 10. So I'm going to start off with 7. Now this time, what I'm going to do is I'm going to count from the end of my number here, and I'm going to count back to where the decimal is. So 1, 2, 3, 4. So what I'm going to do is I'm going to say times by 10. And this time, because we have got a really small number, it's going to be to the power of -4. Okay. The way I like to remember it is if we were going backwards on a number line, we'd be going towards the negatives. And so that's going to be a negative power. Okay, this one's slightly different again, because here we've got 0.00005634. Now I know I need to use all of these digits and I need to make a number between 1 and 10. So I'm going to say 5 and I'm going to insert that decimal 0.634. Now I know that's where my start number is going to be. Now this time, rather than at the end of the number, the reason we did it at the end here is because this is roughly where we put our decimal. So we started with a 7, we put it in here. So we put our decimal here between the 5 and the 6. So we're going to count from where we put our decimal in here to where the decimal was originally. 1, 2, 3, 4, 5. Times by 10. Remember, because we're going backwards, to the power of -5. Okay. Another example then. Write 3.4 times 10 to the power of -3 as an ordinary number. Now this time I've got a negative power, so I know it's going to be a decimal, I know it's going to be a small number, and I know I'm going to have those digits 3 and 4. Now what I'm going to do here is I'm going to write a 3 and I'm going to write a 4, and you'll notice I've just done it to the right of the page slightly, just because I know that I'm probably going to have some numbers here. Now my decimal was here originally, so what I'm going to do is I'm going to count back 3 jumps from this point. So 1, 2, 3. My decimal is then going to go here, and all I'm going to do is replace these with zeros. And because I've got my decimal there, we like to just put a 0 in front as well. So my number 0.0034. Okay, what I've got now is I have got 4 examples for you to have a go at. You have got one example where you're writing a large number in standard form, one where you're writing standard form as an ordinary number, one where you're writing a really small number in standard form, and then another one where you are writing what will be a small number as an ordinary number. Thank you for listening.